All right, so this next one, now this one's a little bit more difficult. They want us to write cosine in terms of tangent. So they want us to take cosine and find a way to write it with tangents. So I'm going to go up and look and see if I have anything that already relates the two that I can work with. And in this case, we don't have any actual numbers. So this one's a little bit different. We're going to go from one identity to another identity. So let's see, I have tangent that is equal to sine over cosine. And I also have tangent squared theta plus 1, which is equal to secant squared theta. And secant is the same thing as 1 over cosine. So really, you can use any of these. There's really more than one way to get to the final result, but there's usually an easier and a faster way. But sometimes if you take the longer way, that's fine, as long as you get to the answer. I'm going to use tangent squared theta plus 1 equals secant squared theta, one of our Pythagorean identities. So that's where I'm going to start. So I'm going to write that down. Tangent squared theta. Actually, they're using an x, so let me use an x. Tangent squared x plus 1 equals secant squared x. So you can use x, you can use theta, you can use y. These are just variables. It really doesn't matter what variable you choose to use. So, but I'll try to stay consistent with what they've used. All right, so let's see. Because I'm trying to get to cosine, let me go ahead and replace secant squared. So I'm going to leave this tangent squared theta, or tangent squared x plus 1 equals 1 over cosine squared. And I need to flip this over because I am looking for cosine, not 1 over cosine. So if I'm going to flip this, I am going to have to flip this. So this is all one thing. I'm going to flip this over, and I'm going to flip this over so that cosine is now on top. So that gives me 1 over tangent squared x plus 1 equals cosine squared x. But I'm not looking for cosine squared. I'm looking for regular cosine. You take the square root of both sides. And that will give me cosine x on this side. Problem over here is 1's a perfect square, so I can have 1 over square root of tangent squared x plus 1, but that leaves you a radical on bottom. So in order to get rid of a radical on bottom, you have to rationalize, multiply both the top and the bottom by the denominator. So tangent squared x plus 1, tangent squared x plus 1. And on bottom, what that does is cancel the radical. And so I'm left with tangent squared x plus 1 over tangent squared x plus 1 with no radical equals cosine of x. And that could be both positive and negative because we took a square root. So, and they didn't tell us this time what quadrant we were in. So depending on what quadrant we're in. All right, so there are more questions like that. I've given you 2 of those, and just like the others, I will post the answers in a separate place. I'll work through them on a different video. All right, and then this is the last example, example 3. So this time we want to write 1 plus cotangent squared theta in terms of sine and cosine. So going back to look at our identities, because of the 1 in these both look like Pythagorean identities to me, so we'll check our Pythagorean identities. So let's see. So I have this one, 1 plus cotangent, and then I don't have 1 for, oh, it's the same one. We're just going to rearrange it for cosecant. So let's see, 1 plus cotangent squared theta. All right, so we are using this identity which means I could subtract one from both sides. So I'm going to use that identity just as it is for the top, but also if I subtract one from both sides, then I end up with cotangent squared theta equals cosecant theta minus 1, which will take care of the bottom. So I can replace both of those. So 1 plus cotangent squared theta over 1 minus cosecant squared theta equals, well, that equals cosecant squared theta over cotangent squared theta. So now I'm trying to get these in terms of sine and cosine. Well, I know that cosecant is 1 over sine squared theta.
I did, yes, sir.
It's division, so divided by cotangent is
no, absolutely. You call me anytime. We're just really busy right now, so I get back to
cosine theta over sine theta. And then I'm going to do 1 sine squared theta. That's keep. Switch to multiply. Oh, these should be squared. Sine squared theta. Cancel. And I'm left with 1 over cosine squared theta, which, yes, is secant squared theta, but they said to simplify these in terms of sine and cosine. So we'll leave it right there as 1 over cosine squared theta. So you have 2 more, just like that. If you would like to do those, I will post those in a separate video if you want to watch those.